Welcome to this session. Please join this peer deck session. I hope you're aware of peer deck. Simply go to joinpd.com and put in this code ZUBPJ, and you should be able to see and join. Let's see, there are 2 students connected. It looks like people know how to do this. Good evening everyone. Let's wait for more people to join. And I see about close to 50 on the Zoom, 68 on the Zoom meeting. Let's see. I hope more people join the peer deck session as well. Okay, so we'll do this. The link is, can you not see it on the, just let me hold on 1 minute. Joinpd.com and then ZUBPEJ. Okay. I'll wait for just 1 or 2 more minutes. Okay, so I see about 40 students on peer deck and a lot of people on the Zoom chat. So once again, those on the Zoom chat, please join the peer deck slides. It's joinpd.com and put in the code ZUBPEJ. Then you will get access to, you'll be able to answer questions. So answering questions, that's on peer deck. Okay, so I think it's 6:03, so we should start. So I'm going to start. Okay, so welcome to this session. Good evening. I hope, I think there's been lots of feedback from many people on Stats 2, in particular, the content being a bit heavy. It does get heavy in these weeks. I mean, I think you need to spend more time. You have to practice. You have to get used to the kind of calculations that you're expected to do. I hope. I think between the live sessions of instructors and all the problems that we give you, you do get enough practice. Make sure you attend the mock exam. See all those questions, make sure you're comfortable with all the questions, and as much practice as possible, right? So I think this session is also meant to give you more practice. I hope this gives you good experience for the upcoming quiz as well. So the topics we'll look at are 2D continuous random variables. So when you have a joint PDF of 2 continuous random variables, there is this region of support in which the joint PDF is non-zero and it has to integrate to 1. There is that complicated looking double integral. Most of the time, if the PDF is flat, it's not too bad. If it's not flat, then you have to use some formula for the integral. So some degree of comfort with that so that it doesn't look totally strange to you. We're not going to ask complicated integration, but still, even if it's simple, you should ensure you don't make mistakes. Then what to do with IID samples? When you have IID samples, and you have to do calculations of probabilities involving those, expectation, variance, and all that. That's one type of question. And then this central limit theorem and the normal approximation, when you have IID samples and you're adding them up or something like that. And then the final topic that's sort of covered in the quiz is method of moments and ML estimation. Given IID samplings, how do you estimate the parameter of a distribution using method of moments or ML? Okay, so these are the topics. These all look like they are all new topics, but really it's nothing different from playing with distributions, thinking of distributions in different ways. So there is some common thread to all this. I hope it's not totally different every time you look at it. Okay, so let's go ahead. The first problem, we're going to jump into the problems right away. The first problem is a fairly straightforward question. X and Y are continuous random variables uniformly distributed in a particular region. So I've asked you to plot the region of support. I don't think you can enter the plot here, but what you can enter is this value of the joint PDF in the region of support. Okay, so it's a very, very, very easy problem to start off. Let's see. So your answers need to go into peer deck. So once again, look at the chat on top. You have to go to joinpd.com, and then even in this shared screen, the code is there on the top right. CUBPJ. So
at the pace at which,
okay, people are slowly getting to the answer. I think this is a relatively easy question. So think about what's being asked here. Need to do some sort of a double integration, but still the region is so simple, right? It's from -1 to 1 and -1 to 1. It's just a square region. And what is the length of the side of the square? It's just 2. So the total area of the region of support is going to be 2 into 2, 4. And from there, the value of the joint PDF should be straightforward. I see about 21 responses. So let me give just one more minute. It's a relatively simple question. It's just a very basic calculation. Let me just see. People are. There's no need to do any complicated integration here, but though you're just used to that kind of solving, you may be doing all that. Okay, so it's about 25 answers. I think it's yeah, I think it's 30 answers now, so that's close to the midpoint. So I should look at the responses. I'm going to show the responses to everybody here. Yeah, 0.25, 0.25, 0.25, 1 by 4, 1 by 4, 0.25. Now there's someone who's got the answer as 4 for some reason. I think they deleted it. 1 by 4. Yeah, I think most people. Oh, there's 4. A lot of people are getting the answer as 4. Okay, 4 is the area of the region of support. It's not the value of the joint PDF. The joint PDF should take some value so that when integrated over the region of support, you should get 1, right? So you assume, for instance, the joint PDF will take a value C. And when you do that integration, you'll get C times 4, and that needs to be 1. So C needs to be 1 by 4. Don't make this mistake. But most people have got 1 by 4. Okay, right? All right, not too bad. First question is okay. So next question has the same distribution.
Sir, good evening.
Yeah. Yes.
Sir, is it okay to ask a question also, or are we just focusing on the questions only?
I mean, most of my
I mean,
lectures
it's a
goes on that.
concept that I want to ask.
If it is related to the question, you can ask. Yeah.
So actually, what I was having difficulty with in this joint distribution, we are given x and y, and we are calculating also, but what does that physically signify, that joint distribution, when we have got not the joint distribution, but the density that we have been able to calculate with two random variables? What will it signify? As a physical thing, what does that mean if we are able to calculate a density jointly?
As a physical thing, what does it mean? As in, it just describes what is the probability that x and y will lie somewhere around that point. I think in my lectures I go into great detail on what a PDF means, what does it mean when the PDF is high in value. I would recommend you look at the lectures, read the
Yeah, so
lectures.
for PDF,
It's the same as the PDF. No? How does it matter whether it's one dimension or
so
two?
for a single variable,
Any number of variables.
but when we will have two, yes, sir.
Even for two, it's the same thing. It's you can think of it as high values of the joint PDF means more likely with the random variable, the pair of random variables will take values there. That's it. Okay.
So will that mean both the values have high probability when we are
I'm,
considering
I'm
joint?
sorry, we
Should
can't go
I
into
interpret?
detailed discussions. I'm really, really sorry. I have about a lot of
Sure, sir.
questions prepared. I want to cover something. This is sort of like a session before the exam. I mean, one or two short questions on the thing I'm presenting here is okay, but philosophical questions about what it physically means and all that, I think we should have had it much earlier. This is not the time. Okay, hope you can understand. All right. Any responses here for
Oh,
this question? So now this is the same distribution. We are asking for probability that x is greater than 0, y is greater than 0, and some sort of a joint probability that x is greater than 0 and y is greater than 0, right? So these are sort of bread and butter basic calculations with distributions just to get a sense of how the probabilities would work. So I'm expecting these questions to be very quickly solved. There are three answers I'm expecting here. I think just by looking at the support. So all these problems, you have to first, always draw the x, y, and then draw the support. And then the event I'm asking, mark it out in the support, and that's the area sort of you have to calculate. Remember the 1/4, right? The joint PDF is 1/4. Don't forget the 1/4. Don't just look at the area there. You have to multiply that by 1/4 to get your final answer. I think hope this is fast. So let me just, in the interest of time, go through and show you the responses. Yeah, half, 1/4. I think most people, there is this point 125. Okay, so there's something wrong here. I think half, and 1/4, 0.5, 0.5, 0.25. This is the correct answer. I think most people have got it. Some people have gotten a different answer. Go ahead and check it. So when you have uniform distributions over squarish regions, these calculations are quite easy. I hope you're not doing some complicated integral here. It should come out a bit fast. Okay, so the next question is maybe slightly different. It just says what's the probability that x is greater than y? Okay, so this should be, so again, draw the xy plane. And then if you want to figure out the region corresponding to the event X is greater than Y, always the trick is what? I mean, ignore the inequality, just make X equal to Y. X equal to Y is one straight line, like the 45-degree line, right? Now, if you want X to be greater than Y, it's going to be one side of that straight line. In this case, actually, in this case, the side doesn't matter. But anyway, so the side is the part to the right of that straight line, right? So this is all stuff you must have seen in Math 1 a while ago. I hope you remember that. So you have to integrate, or you have to find the area of that part. So now you will have a triangle, right? So there'll be a triangle. The base is going to be 2. Height is also going to be 2. And the area is easy to find out. And then don't forget the 1/4. This is the overall 1/4 in the joint PDF. So overall, you can just see that it's going to be half. Okay, so most people, I hope, have it as half. There's also 0.125. Somebody seems to be getting 0.125. I don't know. I think they're doing half and then multiplying by 1/4. I think. So it's actually 2 multiplied by 1/4, right? The area multiplied by 1/4. Remember that. Okay, so 0.5, 0.5, 0.5. Quite a few people have put 0.5. 1/32. I don't know how they got 1/32. Go ahead and check your calculation. The area is 2 and the joint PDF is 1/4. So it should work out okay. Okay. All right. So the next question is a little bit maybe more interesting. Let's try this. So this one maybe I'll do this question. Just write down one part of it. Not do it entirely, but at least write down how this works. So like I've been saying, you always draw this XY plane and then look at the region of support. It's -1, 1, -1, 1, right? So it's this region of support. And this question is asking you for probability that X is greater than Y plus 1. In all these cases, I have to plot X equal to Y plus 1. And X equal to Y plus 1 is going to be this line, isn't it? This line. Yeah, this is the line X. So did I get it right? The other way around it. So just be careful about what you do here. It's very easy to make a mistake here. So just check this very carefully. X equal to Y plus 1. When Y is 0, X is going to be 1. And when Y is -1, X is going to be 0. So it's this line right here. So this is X equals Y plus 1. And what is the region X greater than Y plus 1? This region. So what is this area? Half times 1 times 1. So that's a half. So what is the probability? This should be easy enough, I think. So I gave you a lot of hints. So now you should be able to get the answer very quickly. Okay, so area is half and the probability is going to be, I mean, even from here, the probability is sort of obvious. This overall area, what part is this one? You can quite easily find out. Okay, so there's a question about for a joint distribution, both X and Y should be greater than 0. See the random, so X and Y is basically like the values taken by the random variable. They could be positive, negative, whatever. There's no restriction on what values the random variable has to take. Why is there a doubt on whether the small x and small y should be greater than 0? There's no need for that. X could be negative. Think of like in one dimension. Forget about going to joint PDF now. Right? Think of just one dimension. You have a normal distribution. You have X taking negative values, right? So the values taken by a random variable could be positive or negative. There's nothing stopping you from that. So the joint distribution could have support in negative values of x and y. Okay, so I think these are interesting questions that people are asking. The PDF, the value of the PDF is going to be positive, right? So the density function, if you look at fxy of x comma y, okay, fxy of x comma y, this is always non-negative. Okay, the joint PDF is non-negative. X and Y can take negative values. There's nothing wrong in that, right? So they can have values negative. Okay, keep that in mind. The code is ZUBPEJ. Look at that. Okay, so let's see the answer. I think yeah, 1/8 is the answer. Many people have got that. Okay, so it's not 7/8, it's 1/8. X is greater than y plus 1. Take a look at it. Okay, so the next question is a little bit different. We are moving to another distribution. This is slightly more complicated PDF. It's got more complicated function, and in this case, x and y are taking non-negative values. Once again, draw the region of support. Now it's not flat anymore, so you can't just calculate area. You have to do some, integration, ugly looking integration work. Not that ugly, but nevertheless, something needs to be done. So let's see. So a PDF like this, I just want to comment if you're wondering what would be the difference between this PDF and the previous PDF. Of course, this goes 0 to 2, 0 to 2. That goes from, -1, 1 and all that. But notice this one is not flat, right? If x is 0, y is 0, close to the origin, the PDF is very low in value. Where will the PDF take very high values? Around 2, 2, right? The PDF is going to go close to 4. So this distribution, this joint distribution is non-uniform, and around the origin, it's likely to take values with low probability. Around 2, 2, it's likely to take values with higher probability. So as x and y sort of are going to take, both are going to take higher and higher values, you will have more and more likelihood of the random variables falling in that particular. Okay, so it's sort of a visualization.
Excuse me, sir.
Yes.
Sir, as you have said that the joint density is always positive. So is this for uniform distribution only or always it's positive?
See, the joint density is some function fxy of x comma y. Okay.
Yeah.
This whether it's just equal to c or it is some other value, some other complicated function of x and y, it has to be non-negative. Okay.
So, for example, in the questions where we have to find the marginal density and the joint density is given. So, in these kind of question, which the joint density is given, so can we have joint density as -24xy or like this?
No. That's see, you can have -24xy. I mean, x times y should be negative always. See, you can never have the joint PDF at any region of support to evaluate to a negative value. It's just not possible. It should not happen. It should always take positive values in any region. Okay, in any region which has an area, it should take non-negative values. Is that okay?
Okay, sir. For particular
That's like
region,
a defining
it should be
condition. That's a defining condition for any density, right? It cannot take negative values in a region. Okay.
Okay, sir. Thank you.
So there's a question about in-exam questions are supposed to be like this only. I mean, I don't know. Didn't you have graded assignment questions like this? There were no graded assignment questions like this, is it? Every time somebody comes to a live session, they always ask, they're all surprised by the questions that I ask. I don't know why. I would imagine there are very many graded assignment questions that it's likely that I solved a problem like this in my lectures. It's a very standard sort of bread and butter problems, right? Yeah, there are many similar questions. I think if you have to solve the problems. This course is not a course where you can just show up before the exam and get good marks. You have to make sure you see the graded assignment problems to give yourself a reasonable chance of doing well in this course. Okay. Oh, okay. Okay. All right. Then I misunderstood. These are very simple. Yeah. I mean, I think all probability problems are simple. There's nothing in there. Okay. That's interesting. So we always ask, in our opinion, when I look at the question paper, I always try to make sure the questions are simple. Okay. There's nothing complicated in any of the questions we ask. This is okay. If people converge to the answer, a lot of people have converged to the answer. 1/8 seems to be a very popular answer. Okay, so maybe I will vote for 1/8. I'm not going to solve this in great detail here, but it appears that 1/8 is a very, very popular answer. It's likely that it's correct. So I'll let you check this out. Okay. The next question is a very similar question to before, probability that x is greater than y. And again, you've got to use that C of their 1/8 that you had from before to do this. Okay, so maybe I'll say a little something about this question. So you see here, this fxy of x comma y has this interesting looking thing, right? So it's for x between 0 and 2, 0 else. So it takes values 0, 2, 0, 2. So x greater than y is going to be somewhere on this side. So notice this form of this guy, if you interchange x and y, you have the same joint PDF. So this joint PDF is symmetric about x equal to y. Okay, so think about what this means. You might have studied about symmetry, etc., in your math 1 or not. Just think about what it means. So if you flip, if you situate yourself on the x equal to y line, the picture looks same on both sides. So now, when you observe symmetry of this nature, questions like probability that x is greater than y are very easy to answer. Why is that? You just get half. Okay, there's no need to do any great integration. I hope. Yeah. So you see, half is a very popular answer, and half is a very quick correct answer. 0.0078125. This just cannot be true. Okay, just think about why the answer cannot be so crazy. So it's just half, just from the symmetry of the problem. One quickly does these things. So I think these are the sort of observations which are slightly more fancy, slightly second order, right? If I want to give you difficult problems, I would maybe give problems where these kind of things will make your job easier. It's just up to you. I think if you but in most cases in the exams and all that, we ask just direct problems which don't involve any major trickery of this sort. Okay, but anyway, in this case, the answer is half. What about this one, x greater than y plus 1? Okay, so here you can't use trickery of too much. You can't use. Well, anyway, so let me just say integration is reasonably good enough. I'm not going to wait for an answer for this. I think most of you know how to do it. Already people in the chat have said I'm asking 2 easy questions. So let me just move on to the next one. How would you approach a problem like this? This again is not too hard. It's just the limits of the integration and all that are a bit painful. There's nothing conceptually difficult here, so I'm not going to wait for the answer again. I'll just show you how this problem looks in terms of the integral. So if you do this 0 2 0 2, so I'm looking at x equals y squared, isn't it? How will x equals y squared look? So this will go something like this. If you remember, you might remember plotting this. Maybe I can draw this to scale properly. So when y is 2, x is going to be 4. When y is 1, x is going to be 1. So it'll have a picture like this, right? So yeah, so this one is x equals y squared. Okay, and x is greater than y squared will fall here. So you have
Sir,
to
I believe it's symmetric about x-axis, x positive.
Sorry.
I believe it's symmetric about x positive axis. You've drawn it symmetric about y positive axis.
Oh, what did I do? Okay. Thank you. Thanks for seeing that. So you're saying basically it should be like this. Is that right?
Like a normal C, yeah.
Oh, that's okay. So this is also something I'm doing. I think I'm making all sorts of mistakes here. Sorry about that. So maybe you should be very watchful today. Doesn't seem like a good day for me. So x equals y squared. It's going to go. So when will x equals y squared be 2? So it will be around 1.4 or something, right? So maybe I should draw it correctly. So it will come somewhere here. Is that okay? Is this fine? Right?
Yes, sir.
Okay. So this is x equals y squared, and you can set up an integral and do this problem. It's not really that hard, but I'm not going to wait for people to do it. You may get some highly unreasonable, sort of complicated looking answer. I don't know. It's just something that you can do. So basically, the point is any possible event that you can come up with involving x and y, given the joint PDF, you should be able to do. Okay, so that's all. I think the problems I had in 2D continuous distributions. I think at this level, this is what we expect. And what is maybe more important from a data science point of view is what form for the joint PDF gives you more emphasis, in some regions. So for instance, there may be some type of functions, so some type of random variables y and x, which maybe they tend to be close to, y equals x. Maybe both of them are sort of always going to be equal. And then, you should pick a functional form if you want to model such situations. Which will reflect that, as in the joint PDF should take high values around x equals y, and then it should sort of die down in some fashion. So you can think of such models and all that. So the picture to keep in mind is that from an application point of view, but from, of course, a quiz point of view, we should be able to do these calculations precisely. Okay, so I hope that gives you some bit of a practice, maybe too easy, but still some practice for you to do. Okay, so let's move on to IID samples. Again, very simple questions, straightforward questions. We don't ask anything that's more complicated than the basics in most cases. So here's 20 samples from some discrete distribution. I hope. Oops, I think, did I mess up the distribution? It can't be 1 by 4, 1 by 4, 3 by 4, 3 by 4, right? Oh my God, I messed it up. So just divide everything by half. Apologize for the probability going messed up. It should be 1 by 8, 3 by 8, 3 by 8, 1 by 8. Okay, of course, 1 by 4, 3 by 4, 3 by 4, 1 by 4 is not a valid distribution. So it's 1 by 8, 3 by 8, 3 by 8, 1 by 8. Okay, please make that correction. So there are two expectations I'm asking here. It's I hope this is also easy to solve. Should be pretty quick. Okay, so it's really easy. I think it's 0, 0, 0, 0, 0, 0. Okay, so who has got the answer has got it right. It's going to go 0, 0. So it's basically this 1 by 20 and 1 by 10 are going to come out. You're just going to look at expected value of x1, and each of these things is expected value of x, and that's going to go to 0. It says -3. You can do the multiplication, you'll get 0. Okay, so let's look at variance. The same quantities, x1 plus x20 by 20, and then x1 plus x20 by 10. What will be the variance? Okay, answers are slowly hitting the 20-25 mark. This takes a little bit of calculation. One needs the variance of x. In this case, since the mean is 0, it's just expected value of x squared. Okay. Okay, so I think there's about 30 responses. So let me just see. Okay. Okay. 3 by 20, 3 by 5 seems like a popular answer. So not, I think it's 3 by 20. So 312 is, I think you've forgotten the division by 20, right? So I think, so there's a cat here you have to take. I think there's this x1 plus x2 till x20 divided by 20, isn't it? So you pull out the 1 by 20, and then one needs to be careful. So the variance gets divided by n, and the one of them will be 4 times the other. So 3 by 20, 3 by 5 looks correct to me. Check your, this is 3 by 10 here. I think it should be 3 by 5 because, you know, there's the squaring term, and then you will have that. I think it's, is it 3 by 5 or 3 by 10? People are happy with. So there are 20 of them, and then it's getting, so look at the question here. There's x1 to x20 divided by 10, right? So you will have 20 times something divided by 10 again. So there should be like a 4-factor difference between the two answers. I think 3 by 20, 3 by 5. This 0.15 and 0.6 are actually 3 by 20, 3 by 5, right? I think that's correct. So I think hope you see the 3 by 10. Look at that calculation of that the thing very carefully. There should be a factor of 4 difference between the two. something like getting 1 by 8, 1 by 2. I don't know how you get that. Check that. 3 by 20, 6 by 10. That's okay. 1 by 80, 1 by 20. It's not correct. I think 3 by 20, 3 by 5 is the correct answer. Check your calculation. It's look at that. Look at that. 20 square. The multiplication by 20 has been forgotten here. That's so one needs to be careful. To me, I think this is the chief source of reason why people don't convert their knowledge into marks. There's this small things that you have to take care of. Pay attention to it. I think practice is more or less the only thing that will help you out here. Okay. All right. Let's move on to the next question. So this is a normal approximation question. So even when you have a distribution like this, -3, -1, 1, 3, the distribution of the sum, like x1 plus x20. So if you were to ask the question, what's the probability that x1 plus x2 so on till x20 is greater than 40? If you want to ask a question like that, it's just too painful to do exact calculations. So it's not impossible in this case. I think today's computers would do it for you. But if you do it by hand or get a sense of what's happening, it's really hard. You end up using the normal approximation. So let's see, if you use the normal approximation, you can express this probability as in terms of FC, which is the CDF of the standard normal. What would be this probability expressed in terms of FC? Yeah, I think it's week 1 to 10, but with emphasis in the last week 1 to 8. Yeah. Sorry, week 1 to 8, and emphasis is from week 5 to 8. Okay, so you can take it like that, but when we generally say week 1 to week 8. Okay. You don't have to numerically simplify square roots and all that. You can just leave it in an understandable form. What kind of questions can we expect for quiz 2? I keep asking, everybody keeps asking the same question. What kind of questions? What would you, what is kind? What is the meaning of kind? I don't understand this. You want me to solve this question? Okay, sure. So let's see if people are answering this, about 11 or so. Yeah, I think there's an answer from someone like mock quiz. I think mock is a good indicator of the type of questions you'll get. Graded assignments are good indicators. Those are the type of questions that will come. Okay. Yeah, I will solve this. I'm just waiting to see if there are enough responses. So maybe I'll solve this. Okay. So we've already seen that x1 to x20 is IID x, which is takes values -3, -1, 1, 3, and 3 by 8, 1 by 8, 1 by 8, 3 by 8. So when you do the normal approximation, x1 plus so on till x20 is going to be normal with expected value what and variance what, right?
Excuse me, sir, we can't see your solution.
Oh, sorry. Okay. Can you see now?
Yes, sir.
Okay.
Thank you.
So with mu equals what and sigma square equals what? Let me hear some answers for this. So when I make a normal approximation on x1 to x20, it's the sum. What is the mean? What is the variance? I just have to write the mean of x1 plus x20 and then variance of x1 plus x20. I mean the variance of x1 plus x20, right? What is the mean of x1 to x20? 0. x1 plus x20. 20 times 0. So it's just 0, right? Is that okay? Okay. And then sigma squared is what?
It's 3 by 20.
3 by 20, there's no by and all. 20 times 3, right?
3 by.
It's 60, right? Is that okay? Okay, what's the variance of x1 plus so on till x20, right? It's just 20 times the variance. So that's it. So the normal approximation will have mean 0 and sigma square equals 60. Okay. So now I'm just asking what's the probability that normal with mean 0 and sigma square 60 is greater than 40. Okay. Is that okay? So for that, what would be the answer? In terms of FC, see, remember this is some normal distribution like this. There's 40 here, and I'm asking for this area, right? So the right tail area. So it's going to be 1 minus FC of 40 minus 0 by square root 60. Is that okay? Any doubts on this? A lot of people asked for a solution. Is this clear? Why variance is, see, variance of x1 plus x20 is what? Variance of x1 plus x20 by 20 is what? Okay. So the question is, yeah, it's just in this case, it's x1 to x20 are all independent. So this is just 20 times, it's just variance of x1 plus variance of x2, so on, right? There's no by 20 in the question. So go and check the question. There's no by 20 in the question. I've just said x1 plus x20 is greater than 40. So you have to just look at the variance of this guy. That one will just be 20 into 3, which is 60. This one will be, I don't know, you can take it as 1 by 20 squared times 20 into 3, and that will be 3 by 20. Is that okay?
So this question is not the central limit theorem, right?
So why is it not the central limit theorem?
So it is a normal approximation, but we are but for the central limit theorem we had to divide by the square root of the size.
Oh, see, okay. This confusion.
It's
A lot of
somehow
students
so.
have. I think I do the lectures in one way which gives this confusion to students. Maybe I should go back and look at the lecture. See, there is a way to sort of argue the convergence, and for that I have to show root n and all that, right? Once it comes to just normal approximation and using it for solving problems with respect to FC, you don't have to worry about all those kind of convergences and all that. Whatever is the sum of independent identical distributed random variables, you can simply find its mean and variance and do the normal approximation. Is that okay? Don't worry about all that. That root n is just to say that when you divide by root n, the moment generating function or something of that will go to some constant thing, right? That's all. I think that's just like a proving trick. Forget about that proof trick once that's gone. Okay, so in math, usually when you have convergence, it has to converge to something finite. You cannot go off to infinity or something. Okay, so that's why in the way I develop it, I show how that root n comes. So the results, so when you write convergence to something constant, you want to divide by root n. But when you do the problem, if you do root n also, you'll get the same thing. Nothing will change. The final answer will be the same. When you do problems like this, you just simply use the normal with the expected value and mean. It's the same thing. If you want, you can divide by root 20 and say that is approximately normal 0, 1. Right? You multiply both sides by root 20, you're going to get this answer. It's the same thing. Okay, the answer cannot change. It's just scaling. You won't get anything different. You can just directly do this. Okay.
Okay, sir.
If you like root n, I mean, you can do that also. You should get the same answer. You can't get a different answer. Okay, so there's one question I always ask at this point. Is this the same as minus 40 by root 60? Is this correct?
Yes.
Yeah, yes. So you can also write like this. Both are definitely valid answers. Okay. All right. So there's at least one question that people. How you have to see my lectures. I think in one of my lectures I talk about the symmetry, no, don't I? I don't know. Yeah, there is a symmetry for this FC. Okay, so this normal distribution n01 is symmetric around the origin 0. So whether you go to the right tail or the negative left tail, you'll get the same area. Okay. All right. So here is sort of a word problem. A bunch of word problems around this general principle. I hope I got the numbers okay. So this is a common approximation you'll see quite often when you get into elevators. There will be number of persons and then the weight also. So we're going to try and do some simple problems based on this. So there's a normal approximation here. The question doesn't quite mention the normal approximation, but I mean, you could just make it because there's nothing to do if you don't make that normal approximation. Okay, only about 10 people have written. Of course, the answer will be in terms of FC, right? So you will say FC of what? That's the question. Okay, it looks like these kind of questions confuse people a lot. At least it's not going at the same rate. I think those maybe this is a bit new to you. Okay, so the steps are pretty much identical to what we did in the previous question, right? So let me just quickly show the responses. Yeah, 1 minus C of 400 by 7 square root 10. Yeah, I think root 70. Yeah, 1 minus FC. Is it 40 or 400? I think it's 400, isn't it? Okay. Yeah, minus. Okay. That's 40 by 49. This seems to be, is it 49 is correct? I don't think 49 is correct. But this answer looks correct to me. 1 minus FC. Is it root 70? I mean, so some people are writing 7 root 10. Okay, so there seems to be still some confusion about this question. So maybe I should write down what I think is the answer here. So once again, the question asks you to look at a case where there are 10, with each of them IID normal 60, 7, 7 squared, right? 7 squared is the variance. Right, standard deviation is given as 7. Okay, so variance is 7 squared. Okay, so maybe that caused confusion. Some people saying root 70 and some people saying 7 root 10. Okay, so this is IID, and then what would be the normal approximation for x1 plus x10? It's going to be normal. What will be the mean? 600. Is that okay? What will be the variance? Yeah, 10 times 7 squared, right? So 10 times 7 squared, so 490 or something like that. Okay, so the question asks for probability that normal 600 comma 490 is greater than 1000, right? And this would be, you can draw the probability picture if you like. The normal approximation where this area comes 1 minus FC of 1000 minus 600 by square root 490.
So
So,
why
okay.
are we multiplying with 10 here in the second line?
It's the same thing as what I did in the previous thing. You never asked me why am I multiplying with 20 here. Is that okay?
Okay.
When did I multiply with 20 here? See, and I do expect variance of these things. It's the individual variances added up, right? They are all independent. So variance of x1 plus x20 is the individual variance of each of these multiplied by 20. Same thing you have to do here.
Okay. Okay,
Right?
sir.
So
Thank
10
you.
here, so you have to multiply by 10. See, I don't know, we are not doing anything different. It's the same thing as before, except that some things are given a bit differently. Okay, exact same problem as before, and just repeating it in different flavors. That's all. I mean, nothing is going to change in these questions. Okay. All right. Now that you've done this, I hope the next one, at least the next two, people are going to quickly do. Let me see. Just repetition. There's nothing different here. Okay. The 10 became 16 and then it became 20. Okay, so let's see some answers. Okay, 2 1 minus FC. So what's inside matters. Do you only get 400 here? Always do you get 400 here? Hey, look at this answer. 1 minus FC. For some reason, the 600 in the mean is always kept as 600. That will also change, no? If 16 people come in, the mean is going to be 16 into 60. So you'll have to do 1000 minus 16 into 60, and that's not 400. Okay. And same way here, it's 1000 minus 60 into 20. And that is exceeding 1000. So you'll get minus here. Okay. So people are giving very different answers. I think, yeah, this one sort of captures what is maybe close to what I'm expecting here. So maybe I should do this. I don't know. I think people seem really confused about these things. So in the next case, it's just x1 to x16. It's just basic pattern matching, right? So you're going to do 16 into 16, comma 16 into 7 squared. Nothing is going to change. It's exactly the same thing. So the probability that normal 60 into 16, comma 16 into 7 squared is greater than 1000, right? This is going to be 1 minus FC, 1000 minus 60 into 16. Maybe at this point, we can do that calculation. What is 16 6 are? That's 96, right? 960 divided by square root of 16 times 7 squared. So if you want, you can do the simplification. I think one of the answers was exactly this. 1000 minus 960 is 40. Square root of 16 is 4. 4 7s are 28. So if you want, you can cancel 40 and 28 to write it as 10 by 7. So 1 minus FC, 10 by 7. Is that okay? So there's nothing, it's the exact same calculation as before. Wherever you had 10, you replace by 16, except that maybe when I wrote 600, I didn't write it as 16 to 10. So other than that, it's exactly the same. Okay. Okay. I mean, I can draw a graph or something, but I think it's okay. So if you look at this 960, so it's somewhere here, right? And then 1000 is somewhere here. Okay. So notice what's going to happen for 20. If you go x1 to x20, you're going to get normal 60 times 20, which is 1200, and then 20 times 7 squared. Okay. So this will go off here, 1200. Okay. And when you do 1000 minus 1200, you're going to get 1 minus FC, 1000 minus 1200 by square root of 20 times 7 squared. Okay, so you will have 1 minus FC of minus 200 by square root 20 into 7 squared. Is that okay? So this case, this value, let me see, is it going to be greater than half? Do you think? Do you think this entire value will be greater than half?
Yes, sir.
Yeah, because FC of negative value, right? FC of a negative value is going to be less than a half. So 1 minus FC is going to be above half. So if 20 people are getting in, it's very likely that the lift is not going anywhere, right? So I think this got to be 1000. This is going to go greater than half. Okay, I hope this is clear. There's no major theory here. It's just using these simple calculations over and over again in the same way. Now, this problem can be twisted around. How do you twist it around? You ask this question. Okay. So I don't care about, for a particular number of people, what's the probability. Actually, I care more about this problem, right? Suppose there are n persons who enter the lift. Now this n becomes a variable, right? What is the largest n for which the probability of overloading is 10 power minus 6? Do you think this question makes sense? It's doable? then I might change the probability, right? 10 power minus 3. So everything depends on the way in which you tune the lift and its operating conditions. So how many people you allow in, you can get a good feel whether the probability is 10 power minus 6 or 10 power minus 3. So how do you write this? So you need to do some FC inverse type calculations here. But at least you'll get an equation involving FC of something times n, etc. should be equal to something. So from there, you have to solve for what's inside. Okay, so it's sort of the inverse of the FC will enter the picture. Okay, so these kind of problems are quite standard as well. Let me see if people can give it a shot. Seems to be no responses. Nobody is even. Okay. Okay, so this what is the largest n for which the probability of overloading is less than 10 power minus 6? Okay, so it's need not be equal to 10 power minus 6, 10 power minus 6 or better. Okay, so it's less than 10 power minus 6. Read it like that, and apologies for missing that out. It's just be less here and it's less here. Okay. All right, the responses are coming in very slowly, and we're also a little bit out of time. Yeah, is there a question? Okay, I'm also a little bit out of time, so let me just quickly maybe just show what the calculation is here. It's not, again, anything different from what you've done, except that the calculation is sort of reordered to make it look a bit different. Normal, it's going to be n times 60.
Sir, n is looking to be a quadratic.
I'm sorry.
N cannot be simplified to a single value. It's like a quadratic equation.
Wait, okay. Let me see that. Let me see how it works out. We'll see. Okay. So this is the normal distribution, and I'm going to ask, what's the probability that normal 60n, 7n squared, 7 squared n, sorry, is going to be greater than 1000. Okay, so you'll get this would be 1 minus I'm sorry, is someone asking a question here, or is it some other crosstalk? Okay, so 1000 minus 60n by 7 root n, right? This is the answer. You can also write it in this other fashion, like 60n minus 1000 by 7 root n. I think this is maybe a little bit easier. Yeah, so maybe it become quadratic in n, I don't know, who knows. So this is given as 10 power minus 6, let's say, right? So I want to solve for the n. So you'll get FC inverse of 10 power minus 6. That will give you 60n minus 1000 by 7 root n. Yeah, so maybe you get a quadratic, and you can try to solve for it. I think you'll get only one answer, right? So one of them will be meaningful, the other might be negative or something.
Might be negative.
Yeah, so you don't need to worry about that. So you'll get a value for n, and n, if it's not an integer, you reduce down to the round it down to the integer that's possible. Okay. So you see how
yes.
sort of an inverse problem
can
also be solved. Yeah. Yes.
Yeah, sir. Here, n will be solved in terms of fz inverse.
Yeah. So this fc inverse of 10 power minus 6 will be some number, right? It will be some minus, I don't know, minus 4, 3. I don't know. Maybe I can't recall this. So it will be some number, right? FC
In exam, it will be
10
given us. In exam, it will be given to us. Like
yeah. Any FC inverse, you don't have to mug up. Of course, absolutely not. It will be given. So you can either write it as 1 minus fz of this, or you can write it as fc of the thing minus, right? So that also is fine. So okay, so this is how you can set up these kind of inverse sort of problems. Of course, if you get a quadratic equation, you should be able to solve it. So I think that's okay. So there's no normal table and all that. We usually give you the particular values for which you need will be given to you. Okay, somewhere in the question it will be given. Maybe not in that question itself, but somewhere it will be given. Okay, so if you keep changing 10 power minus 6 to 10 power minus 3, you will get different numbers, and that's what it is. Okay, so I think that's all I had for CLT and normal approximation. So let's go into estimation. We don't have too much time. I'm hoping to finish in the next 15 to 30 minutes. So let's jump into estimation. This is, I think I have about 3 or 4 questions in estimation. This is the last part of the session. Okay, very easy question. 10 samples from Bernoulli P. What is the method of this estimate for P? Okay, you might just remember it by heart, or you can just write it out. I think someone's audio is on, and I'm not even able to see it. How do you see who's making that noise? I don't know if I can.
You can see the participants when they will be showing the mic on.
Oh, I should see participants. Is it okay?
Yes, sir.
Rishi K is not muted.
Yeah, Rishi K, is it? Okay, all right. Thanks, Rishi. I think is close to it. Thank you. Okay, somebody is putting the answer here. You should not put the answer here. You should go to joinpd.com, and I thought I'll have the privileges to. Actually, Manu is asking a question. So this session is clearly about studying for the quiz. Okay, so I believe in my lectures I've pointed a lot to applications, I think. Okay, and you should see the lectures, and if you think the lectures are not doing enough, I think you can. I mean, you should go back and look at the lectures. I think every lecture more or less point to applications. And anyway, as you study more courses at the diploma level and all that, you will see a lot more applications. Okay, it's no problem with that. Be patient with it. But this session is definitely for quiz preparation. This was for helping people get better marks in quiz. Okay, this I'm not trying to go through some general fact. Okay, so this is an easy question. I think most people would do it. It's 4 out of 10. It's very easy. I don't even want to work it out. You just have to equate the distribution mean to the sample mean that you get, and the distribution mean is just P. There's nothing much to do. Okay, so let's complicate the question a little bit. I hope this is a valid distribution. I'm in the habit of missing out on. I think this is a valid distribution. Okay, so there is a random variable x. It takes values -3, -1, 1, 3, and there are the respective probabilities p by 3, p by 4, p by 6, and 1 minus 3, p by 4. And samples are given, right? 5 samples. So 5 samples you observe are -3, 3, -1, 1, 3. Okay, if you were to do method of moments estimate for p, what would be that? Okay, let's see if there are, oh, there's only one answer. What's happening? People are stumped by this question. Let me give it one more minute, maybe. Okay, slowly the answers are going up. So what you do is first find the expected value of x, right? So expected value of x is what? Minus 3 times p by 3 plus minus 1 times p by 4 plus 1 times p by 6 plus 3 times 1 minus 3p by 4. So that's the expected value of x, and equate that to the sample mean. Sample mean in this case is very, very easy. It's just add up all these guys, you just get 3 divided by 5. So 3 by 5 is the sample mean, and you equate this side to that side, and then that would work. Okay. Okay, responses are slowly coming in. We just wait for 3 more responses. Okay, so it's about 20 responses now. Let me just look at that. 0.72. I think 36 by 50 is also 0.72. It's 0.045, 0.72. 0.72 seems to be a popular answer. Let's just check this. I think not enough people have responded. So let me just quickly write down. So the distribution that we have is x taking value -3, -1, 1, 3. And that's, I think, p by 3, p by 4, p by 6, and 1 minus 3p by 4. Okay. So expected value of x, I think, should work out as -3 times p by 3, -1 times p by 4, plus 1 times p by 6. It's 3 times 1 minus 3p by 4. Okay. So if you work this out, what does it come to? One who did this, no one wants to help me.
3
So it's
minus
80
10 by 3p.
Okay, it's what? 3 minus
10 by 3p.
10 by 3p. Everyone agree?
Yes, sir.
Sir,
Yeah.
It's 3 by 4.
I'm sorry.
sir, minus 5p by 6.
Somebody is contesting it as 5p by 6. Okay.
3 minus 10 by 3p is correct, sir.
10 by 3p. More people are getting 10 by 3p. Check your calculation. 5 by 6 looks wrong. I think this other So I think check that carefully. I think 10 by 3p. And so you have to just equate this in method of moments to the sample mean, right? In this case, what is the sample mean?
0.
0.
0.6.
0.6.
3 by 5.
3 by 5.
With what the sample mean is. There are 5 samples here. If you add them all up, you get 3. You just divide by 5, right? So from this, if you solve, do you get p as 0.72? Is that correct?
Yes.
Okay. 18 by 25. Okay, so that's maybe 0.7. Yeah, that looks like 0.7. Yeah. Okay. So it's as simple as that. You know, at many points, I think people ask this question. I mean, are you asking too simple questions? Quite often, these simple questions, you can see the number of places where you can go wrong, particularly if you're nervous in a quiz situation. I think if more people are relaxed, it's easy to write down many of these things. Okay. All right. So now that's part B. Part C, it's a little bit more twisted. So let me wait for you to do it and then we'll see. I hope it's a valid PDF. Yeah, I think it's valid.
Amma.
Somebody is saying Amma. Huh? Okay, I think it's gone on for too long. Statistical mathematics question paper for IIT JAM. Oh, the master's admission. Is it JAM's what? For MSc math admission, no? So basically, I just want to tell you that these are very standard questions, you know. These are the most standard questions. So for instance, if you go somewhere and say, you know, I've studied statistics, people will ask you these things. If you don't answer these things, it doesn't matter what practical application of statistics you know, right? So at the bachelor's level, it's very important to get a grinding on basic tasks. That's what you should aim for. If as you get into more sophisticated practice, the other ideas will come to you. If you don't have the grounding at the bachelor's level, you'll always have that uncertainty about doing anything. So a lot of in this course, you have to focus on that. You should get that right. This FC inverse 1 minus this, that, all that you should do enough in that to know that you can do it. Okay. So don't look at the, you know, I mean, I think I do point out more, as much as possible, some applications and other things. Stats, in fact, there are some nice books which talk a lot about applications. You can find hundreds of resources, but I think it's equally important to make sure you get the grinding right. Okay. All right. Let me see if people have answered. There's only 3 people who have answered. Slightly more difficult question. So there is like this expected value calculation is not maybe the most trivial. It involves a slightly complicated integration. Maybe it's not that complicated. Maybe I should do that in the interest of time a bit quickly. So there's this x which has got PDF a plus 1 times x power a. So in case you're wondering, you know, this type of PDF, it's for x taking values between 0 and 1. You can easily push it to, you know, larger intervals or other intervals if it matters. And then x bar a sort of captures a certain behavior with x, right? So these are all things that you can know about. And now if you do expected value of x, please do a next page. Okay. All right, let me do the next page. X has got PDF a plus 1 x power a. So expected value of x is integral 0 to 1. Oh, so there's x and 0, 1, right? So that's important. 0 to 1 x times the PDF dx, right? So a plus 1 is a constant, it's going to come out, and then you'll be left with x power a plus 1, and that integral is x power a plus 2 by a plus 2, and you have to evaluate between 0 and 1. And that will just give you a plus 1 by a plus 2. Okay, so all right. And what am I going to equate this to? X bar, and what is x bar? .42, 2.8, 3.7, 3.7 by 5. Okay. Hope you get a reasonable value for A from here. You should, I think. Okay.
Sir, can't we get an accurate value for A here by integrating the PDF? We get 1. So that is the exact value of A.
Oh my God. No. You integrate the PDF, you get 1 for any A, right? There's no value for A here. I think you're getting confused with the scaling factor. I've given you the exact scaling factor, A plus 1. So
all right.
This is a valid PDF. For every A, it's a valid PDF.
Okay, sir. Okay, yeah.
Okay. So notice how as A increases, this expected value is going to go higher and higher and higher, right? So how I got 3.7? Oh, so 3.7 is just the sample mean of this. I think I added all this. I got 3.7. Is that wrong? I think it's 3.7. 0.9 plus 0.8 plus 0.7 plus 0.6 plus 0.7. I think that's 3.7. Yeah. Okay. So 3.7 by 5. So solve this. What do you get for A? Let's see if people have got
1.84. 1.84.
And 1.846. Yeah. So that seems to be a popular answer, and you get that 1.8. So that's A. Okay. Is that okay? Hope that gives you some practice with these kind of problems. Okay, so I'm going to go a bit fast here. The ML estimate is a little bit more complex, but in the Bernoulli case, the ML is the same as MM. There's nothing much to do here. How would you do ML estimate here for this problem? Okay, so the likelihood is going to be P by 3 times 1 minus 3P by 4 times P by 4 times P by 6. So it's going to be something like P power 3 times 1 minus 3P by 4 whole squared, isn't it? Okay. You have to differentiate, take log and differentiate with respect to P. You will get something, isn't it? Is that okay?
Yes, sir.
Yes, sir.
The answer. Okay. So you maximize the likelihood of this. Okay. So I hope this is clear. So maybe I'll just quickly write down. So I'm going to write in this page, Himanshu, bear with me. I'm not writing a full solution here. So you get this P hat ML. It's going to be max over P. I think it works out as some P by 3. All those constants don't matter, right? So you just get P power 3, 1 minus 3P by 4 square. Okay. And, you can take log and then differentiate with respect to P. You'll get ultimately one linear type equation. Solve it. You can find P hat. Okay. It's just setting it up in some very straightforward manner. Okay. I hope that's okay. So this is the same question again. So how will you do this for this guy? What is A hat ML? Is maximizing over A of what? A plus 1 power 5. Is that right? Where do I get A plus 1 power 5 from?
Multiplying that.
Yeah. And then you will have here 0.9 times 0.8 times 0.7 times 0.6 times 0.7 whole thing raised to the power a.
So your screen is paused.
Oops, what happened? Sorry. Is this okay? Can you see this?
Yes, sir.
Yes, sir.
Yes, sir.
So it's just the product of the PDFs evaluated at each of those points. And, I have to do a max OAA, and then I'm just grouping the terms very quickly. I get a plus 1 power 5 times the product of all these things per a. Again, how do you maximize? You just take log and then differentiate with respect to a and then equate it, you get something. Okay. You can check whether your method of moments and your ML are giving you the same estimate or not. So, okay, I hope once again this is clear. These are all bread and butter problems. You should be able to directly work on these things. Okay. Okay, let's try this. Somebody wanted practical applications. I don't know. Or word problems, practical applications. I don't know. If you're happy with them, here they are. Here's the question. Let's take a few minutes to think about how you may want to do this.
Sir, I believe P by 2 and P by 2 are there.
I'm sorry?
There's 130 with the probability P by 2 and another P by 2. So it sums up to P.
It sums up
Oh,
to P, and then there is a 110 with
1 minus
probability.
P. Okay, sorry.
I get this right. Actually, I had made a mistake, and Nikita had pointed out that mistake to me. I had put, I think, P by 2, and then maybe something else there. I think half minus P or something I had put. So, should we use ML or moments? See, so that's an interesting question. I don't know. See, that's what happens in practice. Nobody knows the correct answer, right? So you can use whatever you want. I would, in this case, I don't know. I would try both and see what happens. Why not? It's not way too complicated. So the idea is, what's the idea? So you have 5 samples observed from the distribution. So in that 1 over, so you're trying to estimate P. What would be the best P for you to fit? Once you find the P, the answer is simply 1 minus P, right? So that's the estimate of the probability. According to your model, I mean, of course, the model is just a model. In practice, there's no model that fits anything. Or every model fits everything, right? So you have to sort of figure out what to do with those things. But that aside, this is the method here. It's just once you fix the model, once you're happy with the model, you like the model, you say independent with this distribution is what I think is a good fit for how a bowler bowls one particular over, then that's fine, right? So what do? You just execute. That's the drill, that's the grind that you learn as part of stats 2. It's important. Both give the same value. Yeah, fine. I think that's fantastic, right? So if they both give the same value, then you feel good about yourself. You say, okay, maybe this is a good model. Maybe this is something nice. So there's about 5 responses. I'm not going to work it in great detail. It looks like 0.2. Somebody says 2 by 3. But looks like 0.2 is the most popular answer. Now, once again, it's just worded in a different way. I hope you see through the problem. It's just a simple IID sampling problem with a discrete distribution. And you could do ML or method of moments. In a quiz, of course, we will tell you exactly what to use, right? So for you to see, maybe we'll ask you to do both. But in practice, you can do these other things. All right, last question of the day. Last question of the day is another application sounding word problem. Okay.
Excuse me, sir.
Yes, please.
So in the previous problem,
Yes.
what is the power we have to take of this 110? If
Oh,
if we
why should
solve,
you take power of 110?
sir, that is probability of 1 minus p. I have solved it with ml. Then I have to take it with 1 minus p raised to power 1 or 2. I'm confused between 1 or 2.
Ah, okay. See, you have only 5 samples, right? The sixth one, I'm just asking something else, right? Don't worry about the fact that it's the next ball or something. You have only 5 samples. You haven't observed the next one. Okay. In your 5 samples, how many times did 110 occur?
Okay, sir.
1, right? So that's it. You observed only 5. So it's only 1. So 1 minus p is raised to the power 1. And then you have p power 4 into 1 minus p. And that will be minimized at 4 by 5 for p, maximized at 4 by 5 for p. And 1 minus that will be 1 by 5. Okay.
Okay, thank you, sir.
Yeah. Good question. Thanks for asking that. So here's the next one. It's a slightly more complicated setup. I hope I haven't goofed off here. I think it looks okay. Is that a valid? Yeah, it should be valid. X power a. So there's a parameter a here, and I hope the question is clear. So there is some return on some investment that someone wants to model probabilistically, and they're using this distribution, and the factor, it's a multiplicative factor on the investment, and it could go from 0 to 2, and there's a distribution of x power a into 2 minus x, right? You're really hoping, what are you hoping? I mean, so I've said the PDF is proportional to this. There will be a constant, a multiplication constant, to make sure that this is a proper PDF. I don't know what it is. It will be some function of a. So does that matter? Do you have to find that constant? Or can you do
I
the
think we
problem?
need to divide it by 2 to make it from 0 to 1 and apply some known distribution.
No. So I've given the PDF for x, right? I'm saying it's going to be modeled like this: x power a times 2 minus x, x taking values in 0 to 2. Constant does not matter. Is that really true? I mean, what if the constant depends on a? Won't it depend on a? I'm trying to estimate a, right? And if I do ML, for instance, or even method of moments, that constant will enter the picture or not? Go back and check your a plus 1 power x power a. So did a plus 1 not play a role? Okay. See, notice this prior data is actually 5 IID samples of x, isn't it? What is the first sample? Okay, why are there 2 parameters? Why are there 2 parameters? What are the 2 parameters?
First one is the investment, and the second one is the return.
No. See, okay, so maybe that part of it is not clear. Whatever t may be, right? Whatever you invest, I'm saying the return is modeled as x times t, where x is this random variable. Is that okay? What
X is a multiplier on t. It's a linear multiplier.
Yeah, it just multiplies t. X multiplies t, right? So suppose x is 0.5, right? In that one realization, x became 0.5. Then you made a loss. You invested t, you got back only t by 2. Is that okay? Suppose when x is 1.5, then you got a 50% benefit, or if x is close to 2, 1.9 or something, then you got a huge benefit. Is that okay? Okay, so here are the prior samples. Okay, so in the first case, what is the value of x?
1.1.
1.1. In the second case, what is the value of x? 0.9. 0.9. In this next case, what is the value of x? It's 1.2. 1.2, right? In the next case, it's 1.4. The final case, it's 1.8. Is that okay? So instead of telling you that, there is this distribution, and then I observe 5 IID samples of that distribution, I'm giving you that same information in one convoluted way, okay, in terms of problem solving. Okay, in terms of practical application, these kind of things are very, very, very hot ideas, right? So based on prior data, you have to first fit some sort of a probabilistic model. This model, I'm not claiming it's any good or anything, but it's just some model, right, from which this data could have come as an IID sample, and then I go in and find the best possible parameter, etc. Is that okay? All right, so let me maybe quickly show you something here. The first thing to check, I'll go to a new page. First thing to check is x power a, so c times 2 minus x integrated from 0 to 2. What will you
Sir,
get?
you haven't changed the page.
Oops, sorry. Is that okay? So this one will be what? So c x power a plus 1 by a plus 1 evaluated between 0 and 2, right? Minus c x power a plus 2 by a plus 2 evaluated between 0 and 2. Okay, so you get here c times 2 power a plus 2 by a plus 1 minus 2 power a plus 2 by a plus 2. Is that okay? All right, so you get c times 2 power a plus 2 times divided by a plus 1 times a plus 2. So quite a complicated formula, and then this should be equal to what?
1.
Okay, so this gives you c, right? First, c is a plus 1 times a plus 2 by 2 power a plus 2. Wow, what a complicated looking PDF. So what are my samples? My PDF is X has got PDF a plus 1, a plus 2 by 2 power a plus 2 times x power a times 2 minus x, right? And then I observe 5 samples. What are the 5 samples? I just gave you, I think, 1.1, 0.9, 1.2, 1.4, 1.8. Okay, that's it. As simple as that. You've got a PDF, you've got a
Sir, if you could entertain my wild idea, if I set c is equal to 1 by 2, the range reduces itself to 0 to 1, and it looks similar to a beta distribution.
Yeah, this will look similar to a beta distribution. I agree, but I'm look at the event I'm interested in. No, I'm interested in the probability that of what? A new investment will result in a gain, right? What is that event?
Basically, greater than 1.
Yeah, probability that x is greater than 1. So probability that x is greater than 1 is what I'm interested in, isn't it? What will it be first? You can integrate here, right?
Yes,
from 1 to 2, from 1 to 2. And if you are doing a change of scale for your original thing, you'll have to do the change of scale here. Maybe you do 0.5 to 1 or something, right? You may get like a beta distribution or something like that. Yeah, you're right. I think you can do the problem that way. I'm sorry. Yeah, you can do the problem that way. That's also perfectly fine. But I think I was just doing it directly. Is that okay?
Okay.
So here you will get some. So this probability of x greater than 1, you will get some function of a, isn't it? It will be something. I don't know what it is. Some 2 power a plus 2 something and all will be involved. Okay. What you can do is you can find a from the samples and then plug it into the probability of x greater than 1 expression and get an answer. That's one possibility. Those kind of things are called plug-in estimators. Okay, so this is the word, okay, fancy word for that. So you find the unknown parameter and then plug it in. And quite often you will see a lot of people will directly try to estimate probability that x is greater than 1. Okay, they will not like this, this complicated way of finding a and then plugging it in. They may say, I'm going to try to directly estimate probability of x greater than 1, and some sophisticated ways are there to show that those, in some cases, may be better than doing plug-in and all that. Okay, so I think the last two problems, I think Samraj was really worried. He doesn't want word problems in the quiz. I mean, this last problem is definitely slightly more complex than what we would ever ask, but I think this is a sort of flavor that in practice you'll see people use statistics in. There will be some phenomenon, there will be a probabilistic model, and we'll go back and forth. We'll keep changing the model, we'll keep changing. So if this doesn't fit, we'll change this, we'll move it around. And so this bread and butter problem of once the model is fixed, how do you find the parameters, right? And using the parameters, how do you plug in into other things that you're interested in, right? So I'm interested in whether or not there'll be a gain. I'm not interested in some unknown A, right? I don't even care about that A. You can't go to your customer if you're a banker and explain, you know what, I have this complicated beta distribution type model and this parameter A I'm finding out. They don't want to listen to you. They just want to say, what is the probability I'll gain? And what is the probability I'll gain more than something, right? So that's all they're interested in. And you should know, how to get there. And you may use some fancy tools, but where you get to is also equally important. Okay, so if you got too scared by the last question, don't be too scared. It's sort of slightly convoluted, but it's very typical of such cases where you use this. Okay, so I'm going to stop here. Any comments or questions from anybody? People are happy. This is the last question. Nobody has responded. Of course, it's a slightly more complicated question.
Sir?
Yes.
Sir, if we apply, how can we apply Bayesian estimation in this problem? Like, what will be the prior in likelihood into prior, like we do in Bayesian estimation?
Okay, Bayesian estimation is not part of quiz, right? So I'm gonna bail with that excuse. Maybe when I show up for the final exam and help people do it, at that time I'll give you an example. And even in my one of the problems I discuss, I think in healthcare or something, I talk about an application of this kind of Bayesian priors, informative priors, and all that. So look into it. Look at those lectures. You'll get some idea from it. Okay.
Yes, sir.
Okay.
Thank you, sir.
Yeah, I think a lot of people are asking for an easy quiz. I mean, let's hope for the best. I think many of you are well prepared. All the best. Be relaxed. Explain CLT in last of the session. In the CLT part, how n into delta into sigma came. Okay, so why don't you, Himanshu, why don't you post this question on Discourse? I'm not able to recall exactly what this is. Please post that question on Discourse. I think Nikita or even I will take a look at it later. Okay, please do that. Okay. All right. Thank you. Thank you, everyone. Have a good night.
Thank you, sir.
Okay.
Thank you, sir.
Do I trade in the stock market? Absolutely not. I don't do any of this.
Thank you, sir. Thank you, sir.
Okay. Bye.
Sir, actually, sorry, sir. Is there a way to, I mean, sir, I missed the mock because there were multiple mails sent changing timings. So I wasn't able to write the mock. Is there any alternate way, sir, to write mock someone who missed?
Okay, I'm not able to answer that question. Is Nikita or someone here?
I believe the mocks are still available for answering.
Yeah, the mock is still available on the portal. You can write it anytime you want.
Mock is converted into an assignment, is it?
Yeah, yes. So you can write anytime you want.
Today is a submission date. Right?
Yeah, I will post it in Discourse, ma'am, because I am unable to view any. Oh, okay, right.
It will not be a time. It will not be a time thing for you. You should time yourself. It's just available as an assignment. That's all. So I'll urge all of you, in case you're worried about time yourself. I mean, you pick up the mock and time yourself and solve it. I think it's extremely important to time yourself. I think only then, with repeated practice, you'll understand how to optimize time in an exam. Okay.
Yeah, sure, sir. Thank you. It's available. Thank you, sir. Thank you. Yeah.
Okay. All right. Bye-bye. Good night. Bye.